go over this other video about our 3-2-3-4 equation derivation. So, to get started, I'm going to cover how to get the position equation with no final velocity given in this one. So to start with, let's cover a quick equation velocity time graph, and we'll cover a quick concept. When we have a straight line, our velocity of some v initial in some time frame, and if it's the same and it happens over a period of time, then the area, if it's a v and t plot, is going to give us the displacement. If that was, say, 3 and this was, say, 2, be 2 times 3, and we know this would be meters per second times seconds if we were using SI units. That would cancel nicely, and we'd be left with 6 meters. Right, pretty simple. But if we were not having a flat line, if our line was curved somehow, or straight upward, like that, we would need to find, if we want to find this distance, we'd have to find the area of this triangle, and we'd have to find the area of this box, or rectangle. And to do that, we need to know the final position, which is up here. That's where it ends. Because then our height is going to be some change in x. And then our length is just some time frame. And we know the area of the triangle is just 1/2 base height. Right, and then we know the height's delta x, we know the base is some time, or not delta x, delta v. Sorry. Height's delta v, base is time, and we also know to find what delta v is in terms of a and t. We can use this equation. Then solve for time, and we get AT equals delta V. Alternatively, you could find what delta V is using the fact that delta V is VF minus VI. And you could plug in what VF is, which you know is AT plus VI. Then plugging in that AT plus VI minus VI, you would get that it's just AT is your delta V. Same thing. So once I do that, I will find my area of the base, which should be the area of the rectangle, so v initial and time, plus 1/2 the base, which is time, times my height, delta v, or AT. And this is going to simplify, and I'm going to get my first form. One half ATT is squared, t squared. That's nicely going to be our first answer. Now if I want v initial by itself, all I have to do is subtract 1/2 AT squared to both sides. And then I have to divide out t, which I will do, and I'll put v initial over here. equals delta x minus 1/2 at squared over time. And in mine, I think I simplified this so that t canceled here, and you had 1/2 at and delta x over t, but same thing if you don't choose to do that. So here's our second one. Our third one is with a. Let's do that on a different page. So that's going to be a little more tricky, but not too bad. All right. So for this one, we have to put VIT on this side. Delta x minus VIT equals 1/2 at squared. And then I have to find the reciprocal of this, which is going to be 2 over t squared. And I knew that because t squared over 2 times a. So what I could rearrange this to. Same thing. Okay. So once I do that on this side and on this side, it will nicely work out for me, and I will get a equals 2 multiplied by some x over time squared. And for the time one, I think I will do that in a separate video.